Yes, once again, student, good morning, everyone. Today we are going to study very important, that is a fixed probability vector in joint probability distribution. It will come under the unit joint probability distribution. Yes, please concentrate here. So you can see in the test, they may ask such definitions. They may use what is the condition they are going to ask. Such one marks questions they are going to ask. So please be concentrated on the definitions and conditions and notes what I have given. So here fixed probability vector, what is fixed probability vector, students? It is for stochastic process P of order M. A probability vector V is equal to V1, V2 till Vn. If V into A is equal to V, regular matrix is irreducible and regular stochastic matrix is always positive, friends. So you can see these are the two conditions where you can see stochastic process for the fixed probability distribution P of order M. This probability vectors, we are going to denote this by V1, V2 till Vn. If this condition satisfies, means Va is equal to V. This condition must be satisfies. And you can see in the last example also we have seen whatever the values, whatever the vectors are there, there must be positive. Yes. In the internal, they are going to ask 1 marks questions. So such questions they are going to ask. What is the condition for fixed probability vector? Suppose if this unit is not there, but in the next test, like they are going to ask the condition, that is what is the condition for fixed probability vector, and you have to write Va is equal to V. That is a fill in the blank. So here you can see what is regular matrix is irreducible. Here we are going to consider this one of the note, and regular stochastic matrix is always positive. So please remember this. So I think in the last class we have seen, I have already gone through this. Yes, this is what we have used in the last class. So you can see this condition and definition of stochastic matrix we have seen, that is P is the square matrix with each row being a probability vector. In other words, all the entries of P are non-negative. First condition, please remember, always the probability will be non-negative, and in the stochastic matrix the sum of the entries of rows is always 1. So such 1 marks question they may ask in the internal test and final exam. Please be prepared with such questions also. So to solve the example, we'll follow some steps. So first we will going to take V is equal to X, Y if the matrix is 2 cross 2. If it is 3 cross 3, vector will be V is equal to X, Y, Z. And where you can have to take consider this condition, that is X plus Y is equal to 1. That is sum of all the rows X plus Y will be always 1. Suppose it is 3 cross 3 matrix. What will be the condition? X plus Y plus Z is equal to 1. Okay. Next, you have to use this formula V into A is equal to V. This condition you are going to use. Then using X plus Y is equal to 0, substitute the values. Find the value of X and Y, which are fixed probability vectors. So here we are going to, if you find X and Y value, they are the fixed probability vector. So immediately we'll go with the first example, students. So be ready with your calculation part. So this is our first example. I'll just rewrite the question once again. So it's a very simple question. So now we'll start the example. So I'm going to take this. Okay. So now you can see we have to write first condition, student. Always remember in the exam also the marks will be given here. You have to write the condition. So we have to find what? The vector. That is, this is 2 cross 2 matrix, so I have to take here X and Y. Please remember this. And what will be the condition for this, students? Yes, it is X plus Y is equal to 1. Please remember this. And we have VA is equal to V for fixed probability vector. So you can see find the unique fixed probability vector of a regular stochastic matrix A. They have given this matrix A of 2 cross 2. 2 cross 2. So we are going to substitute the values now. First I am going to take the VA is equal to V. This condition I will take. I will substitute the values here, students. That is, V is nothing but X, Y I am going to take. And then I am going to substitute here A value. What is A value? It is 3 divided by 4, 1 upon 4, 1 upon 2, 1 upon 2. So this is A. this is equal to, again it is V. This condition satisfies, then we say this is nothing but fixed probability vector, that is unique fixed probability vector of a regular stochastic matrix. So now students, already you have come across the matrix, right? Matrix multiplication, matrix addition, subtraction, right? So we'll just multiply this matrix. So first I'm going to take first row, first column, I'm going to multiply here. So x is multiplied to 3 upon 4, so this will be 3 upon 4x plus, this will be again in matrix only, plus, so corresponding value again you are going to take y is multiplied to 1 upon 2, so this is 1 upon 2 y. So this is our first row first column value. Next, first row second column, this is our second column, students. So multiply corresponding values, it is 1 upon 4x plus 1 upon 2 y. So these are the corresponding values we have multiplied, and which is equal to x, y. So you can see LHS is equal to RHS. That is what the component says, that this is equal to x and this value is equal to y. Therefore, we'll solve like this. So this will be like this, students. So I'm going to take here 3 upon 4 x plus 1 upon 2 y is equal to x, and 1 upon 4 x plus 1 upon 2 y is equal to y, students. Now I'm going to simplify this equation. So first I will consider this equation 1 and equation 2. You are familiar to solve the equation, students. You can please try this, but you should remember this condition also, it is there, that is using x plus y is equal to 1. Please use this condition and you can simplify this equation. Okay, so what I will do here, I will just take y value. This will be 1 minus x. Just I have brought this plus x on this side. It will be minus x, students. So I'm just put this value in equation 1. So when I put this value in equation 1, so equation 1 will be like this. It will be 3 upon 4x plus, you can also substitute in the calculator and please tell me the answer if possible. Yes, so I've just substituted y value. You can see this y value is nothing but now 1 minus x. So now you can simplify, students. So I'm just multiply here by 4. Everywhere I'm going to multiply. So if I multiply here 4 will get cancelled. We get only 3x plus. If I multiply here 4 upon 2 means here it will be 2. This is equal to, here also I'm going to multiply 4. So I'm going to get here 4x, students. Now you can simplify this. This is 3x plus 2 into 1 is 2 minus this is 2x is equal to 4x, students. So all the 4x you can bring that side. So what will be these values? This I'm going to bring on this side. So plus will become minus, minus will become plus. So 2 remains here, 4x remains as it is. Next, this 3x minus 2x will become, yes, you can take here 3x minus 2x will become here x value. So this is again plus x. So if I bring on this side, it is going to become minus x. Please remember, you can just simplify this here. So like this it is 3x plus 2x, that what I have done here. Now further if you simplify, students, 4x minus x will become 3x. So what will be the x value, students? Yes, very simple. Therefore x is equal to 2 divided by 3. Is it clear? Any doubt here, student? Please ask me the question if you have any doubt. Yes, unmute and tell me if you have any doubt to solve the equations. Okay, now you can see by using again x plus y. So using the equation x plus y is equal to 1. So substitute x value, that is 2 upon 3. We have already calculated this. So y is equal to, I'll bring this plus 2 upon 3 on this side. It will be minus 2 upon 3. So y is equal to, if you take multiply here 3 and multiply here 1. So you will get here LCM 3. This is 3 minus 2. Or you can directly put it in the calculator, student. So therefore you will get this as y is equal to 1 minus 3, student. Therefore, what is this condition now? V is equal to, we get this as xy, which is nothing but your 2 and 3 2 divided by 3 and 1 divided by 3, okay, which is required fixed probability vector, students. Okay, I think there is no doubt. So because you should be fast now. Okay, this is first example. So try for second example, students. Please try for second example. I will also solve this example, but you should be fast than me now. So this is our second example, that is, yes, find the unique fixed probability vector of a regular stochastic matrix. So same question. Now you can take, so simplify this, students. I will take this solution. Okay, I can see what I have to use here, students. Yes, I'm going to have to take, we have V is equal to, because this is 3 cross 3 matrix. Please remember, whenever this is 3 cross 3, we have to take 3 variables x, y, z. So that will be our fixed probability vector, students. So please remember, and also you have to remember that the condition, if there are 3 variables, this sum of this is always equal to 1. Please remember this, for the stochastic matrix this is equal to 1, such that, what will be this such that, student? Please remember this formula, that is VA is equal to V. So therefore I am going to take this as VA is equal to V. I can just simplify this, students. Substitute the values. What is V here? Yes, it
Hello,
is
sir.
X. Ah, yes, please tell me.
Sir, sir, what is that VA is equal to V? What it means?
This is the condition for fixed probability vector. If this condition satisfies, see here, what is the definition says, for stochastic process or transition matrix P of order M, a probability vector will be there. V is equal to V1, V2, Vn. If V into A is equal to V, this condition satisfies. If this condition satisfies, then whatever the values we get x, y, z, this vector are nothing but fixed probability vectors. Is it clear? So even in the steps I have given C. Suppose you are going to take this as vectors x, y. So just we will substitute in this condition and then we'll find the value x and y. So we are trying to find fixed probability vector, right? So the only one condition we have, that is VA is equal to V. That is the condition given by the fixed probability vector, students. So therefore I have to take this condition. Okay, by definition, this is by definition. Please remember. Is it clear, student? Any doubt still? You can ask me. Shall I proceed?
Yes, sir.
Okay, thank you. So now substitute the value of A. What is A here? 0, 1, 0, 1 upon 6. This is 1 upon 2. Please try yourself, student, now. If possible, tell me the answer. 1 upon 3, 1 upon 3. So this is a 3 cross 3 matrix. It will be lengthy. Therefore, I will show these values. How to calculate in the calculator. It will be very simple. Okay, now again multiplication of the matrix. Already you are familiar with multiplication of the matrix. Okay, so again I am going to take here, this is first row, multiply to the first column. So okay, so this will be, the values will be here 0 into x 0, and this is 1 upon 6 y, and z is equal to 0 0. Okay, so next again first row to the second column, 1 into x is 1 plus 1 upon 2 y plus 1 upon 3 z, students. So this is the first row, second column we have multiplied. Next again first row, third column. So this is our third column. Okay, x into 0 0. Okay, next 1 upon 3 y plus corresponding elements you are going to multiply. So this is equal to x, y, z. Okay, so now again comparing this equation, LHS is equal to RHS. These values are equal. Yes, corresponding. This is equal. LHS is again equal to RHS. Sorry. These are corresponding elements are equal. So I'll just write like this. That implies 1 upon 6y is equal to x, and x plus 1 upon 2 y plus 1 upon 3 z is equal to y. Similarly, we have here 1 upon 3 y plus 1 upon 3 z is equal to z. First, we'll simplify this. I can write this like this. 6, I will bring this side. So I can write like this. 6y is equal to 6x. Similarly, I can simplify here. So here you can take 2 and 3. If you take the LCM, it will become 6. I'm going to take 6 as the LCM. Therefore, I will multiply here 6. So this is 6x plus 6 upon 2. How much, students? It is 3y plus 6 upon 3. 6 upon 3 will be 2z. Okay, this is 2z. Right, again 6 you multiply here, it will be 6y. Okay, next. Similarly, I will multiply here because LCM is 3, 3, 3, 3. Divide 1 upon 3, 1 upon 3. So I'm going to multiply 3. This is 3. If I multiply 3 will get cancelled. Y plus 3 will get cancelled. Again here z is equal to 3z. Okay, further I can simplify. Yes, definitely I can simplify this. I'll bring this 6y here. It is going to become minus 6y. So you can see minus 6y plus 3y, it will be minus 3y. Is it clear? So this equation I can write like this: 6x minus 3y plus 2z is equal to 0. Similarly, you can take this z outside here. If I take this z, this will be y is equal to 3z minus z, y is equal to 2z. So I'll just simplify this equations one by one. I'll take this y on this side. So I can write the same equation like this. Please concentrate. This is very important step. So 6x plus y. If I bring it on this side, it will become minus y plus z is not there. Therefore, I will put there 0 into z is equal to 0. Okay, these are the equations we are going to get here, students. Similarly, I will bring this y on this side or 2z on this side. Any one will be okay. So what I will do here, I will bring y on this side. Therefore, the equation will be like this. X is not there, so I'm going to take 0x. Okay, no problem. Then y is on this side means y will become minus. I'm going to take minus y. Then here plus 2z is equal to 0 plus. Again, you have to remember, we know that. What we know, students, very important. The condition x plus y plus z is equal to 1. You can use this equation as you want. Suppose if you take here z is equal to 1 minus y minus x, and then you substitute the values here, x values, you can take here directly. X value, I think you will get, yes, this value you can substitute here. Yes, z value you can take here and substitute. Instead of doing this all things, you be ready with the calculator. Wait, I will show you the calculator. So on your calculator, students, very important. Okay, I'll just show you. Can you see the calculator, students? Is the calculator visible? Okay. I don't know why this is not actually coming here. I don't know. Okay, no problem. But I will show this in the calculator. Yes. Can you see the calculator, students? Is the calculator visible? Okay, now just on the calculator, press mode, go to equation 5. Yes, is it visible here? Go to mode equation and then you can see this. You will get the options like this. Okay, then go to second button. So you must get, everyone must get on your calculator like this. Yes, please unmute and tell me, students.
Yes, sir.
Yes, sir. Yes, sir.
Very good. So I'll come back to, yes. Now what you have to do, as you can see, you are going to take the coefficient. So from this value, take the coefficient of x is 1, 1, y coefficient is 1, z coefficient is 1, and the last value is 1. Then you can take this equation, that is 6 minus 1, this is 0, 0, and you can please take this equation, this is again 6 minus 3, 2, 0. Substitute in the calculator, students. 1, 1, 1, 1. Next it is 6 minus 1, 0, 0. Next it is again 6 minus 3, 2, 0. You can solve like this, or you can also go with like this. So if we simplify this equation, both equations you can take here. Yes, tell me the answer, students. Yes, you must get this. I think if you put equal to, you are getting the value x is equal to 1 upon 13, y is equal to 6 upon 13, and z is equal to 6 upon 13. Yes, please check.
Yes, sir.
Is it clear?
Yes, sir.
So everyone are getting same answer?
Yes, sir.
Very good. So it is very simple. I have made it. Okay, so directly you can take this value. Therefore, so you can take
Sir,
here.
what about
Therefore,
the third equation, 0x minus y plus 2z is equal to 0?
we have already calculated x, y, z. Finish. Why we require this value? No.
No, sir, in that matrix format, sir, substitute. If we take the third equation, it will come as same or different.
No, same. Definitely. You can please try that. Yes, very good. You can substitute. Instead of substituting this value, you can also substitute 0, minus 1. This value you try. Just see. I think you must get the same. That is nothing with that this one equation. Minus 1, 0, 0. You can try substituting this 0, minus 1, 2, 0. Wait. I will also substitute the same thing. That will not make any difference. Minus 1, 2, 0. But try to take this values only.
Sir, for that I'm getting as 1 by 10 and different 3 by 5 and 3 by 10.
Yes, if you take this value, it will be different. Definitely. If you take this value, I think you will get like this. That is x is equal to 1 upon 10 you will get, right? And this is 6 upon 10 and this is 3 upon 10. X, this is x, y, z. So in exam you directly type both the equations and try. You will get this values. Is it clear? So therefore, so you will get like this 1 upon 13, 6 upon 13, this is 6 upon 13. Similarly, you will get and 1 upon 10, 6 upon 10, and this is 10 upon 10. So both you write down, no problem. So that will give you, that is fixed probability vector. Okay, which will give you fixed probability vector, students. So this is the required answer. Okay, very good. So any one will become your correct. Don't get confused. So please try substituting both the values. With this, you write like this. In one matrix, you write like this. In second matrix, you write like this. And here we get x, y, z like this. And here we get x, y, z like this. So, okay, next we'll go with the next problem. That is, yes, third example. Okay, now you can try this example, students. Third one, what it is saying. Yes. First, it is asking that show that P is equal to is a regular stochastic matrix. So when it will be regular, students? So you can solve it very easily. When it will be regular, I already given here a point. Note. So when it will be regular, when it is always positive, when the next matrix will become positive. So when this will be regular. So I'm going to take here P square. Let us see. P into P. So next matrix, that is, if you find that if P square is positive, then we say this matrix, whatever they have given here, it is regular, student. So please try substituting in your calculator. Multiplication of two matrix, I think you can do. This is 0, 1, 0, 0, 0, 1, 1 upon 2, 1 upon 2, 0. So you can square this in your calculator. I think there is an option. I will show you. So wait. Okay. I think there is an option here. Yes. Go to the first mode, then go to 6, 1, 1. I think you must get this matrix like this. Once again, I will repeat this. See, mode 6, mode 6, 1, 1. That is 3 cross 3 matrix. Is it visible, students? Yes, you must get this like this. Now you can see, substitute these values, that is 0, 1, 0, then 0, 0, 1. Then 1 divided by 2 equal to 1 divided by 2 equal to 0. Yes. Okay. After substituting the values, students. Yes. After substituting the values, what you have to do? Press AC. Yes. Press AC button. Then again go to shift. Shift. Yes. Go to matrix. There is matrix 4. Then press 3. I think mat A will appear. Is it visible in the screen? Yes. Mat A will appear. So what you have to do here, students? Just press the button X square. So X square, if you press, it will become mat A square. Okay. So when you take this as mat A square, then press equal to. Yes. When you press equal to, friends, so you can see the value I have calculated here is 0, 0, 1. This is 1 upon 2, that is 0.5 means 1 upon 2, 1 upon 2, 0, 0, 1 upon 2, and this is 1 upon 2. Means this is positive. Positive. Similarly, you can try for p cube. So how you will try for p cube? Yes, it is p square into p. Yes, it will be also positive. Next, go for p4. p3 into p. It will be positive. Directly, I will go for now p5. Therefore, we can at least show this values. So this will be equal to 1 upon 4. You please try 1 upon 4, 1 upon 2, and this is 1 upon 4, 1 upon 2, 1 upon 4. Next, this is 1 upon 8, 3 upon 8, and this is 1 upon 2, students. Means that all these entries are positive. Therefore, the last condition is that P is a regular stochastic process or matrix. Therefore, this condition satisfies that whatever P is there, we have given it as stochastic matrix. Now go to find associated unique fixed probability vector, students. So how we are going to find the fixed probability vector? Okay, start solving again. Take V is equal to x, y, z, where x plus y plus z is equal to 1, such that, so here you can see P they have taken as matrix, therefore Vp is equal to V by definition. Please remember this. So I'm going to take here again Vp is equal to V by definition of fixed probability vector. So again, simplify, students. X, y, z you can take, and then you can substitute the value of P. What is the value of P, students? It is 0, 1, 0, and this is 0, 0, 1. Please now you can try this. Substitute in the calculator and tell me what is the answer. This is equal to x, y, z, students. Okay. Now multiplication of matrix, students. Row is multiplied to first row is multiplied to first column. Okay, 0, 0, 1 upon 2, z you will get. Next, x, 1 into x, second row, first row, second column, multiply. 1 into x, x you will get 0, then 1 upon 2, z you will get. Here again, x is 0, third column, first row, third column you multiply. X into 0, 0, this is y, and z is also 0. So again, you will get this equation, student. So please try, tell me the answers. Corresponding elements are equal. Please remember, this is equal to this. Similarly, this is equal to this, and this is equal to this. Therefore I can write like this: 1 upon 2 z is equal to x. Similarly, x plus 1 upon 2 z is equal to y, and this is y is equal to z. So further, if you simplify, yes, I can simplify this equation, that is 2x plus z is equal to 2y. I'll just multiply here 2, and here I will multiply again 2, so this will be z is equal to 2x. So I think this is equations have already simplified. Okay, now using the condition, what is the condition says? Yes, it is x plus y plus z is equal to 1. Substitute in the calculator, students. Yes, even I will substitute, repeat the same procedure, go to mode, then 5 equation you will get, then 2. Now you can substitute like this. This is 1, 1, 1, 1 from this equation. And from this equation, I will take this on this side. So this will be 2x. Y is not there, therefore I will take 0. And this is minus z is equal to 0. Then I will get this equation as 2, 0, minus 1, 0. Okay. Then go to this equation. This equation you can take. Simplify this equation, I will take 2y inside. Therefore, this equation I can write like this: 2x minus 2y plus z is equal to 0. So therefore, in matrix, this will be 2 minus 2, 1, 0. So now you can substitute, student. Tell me the answer, students. 1, 3. One, one, one. Next. 2, 0, minus 1, 0. Next, 2 minus 2, 1, 0. Yes. To try for this matrix, also I will give you another one. This is 1, 1, 1, 1. Now what I will do, I will take this equation, the second equation I will take, and third equation I will take. I will just simplify this. I will bring z on this side. So x is 0. This is plus y minus z is equal to 0. So now I will take this equation, second equation, that is 2. This equation I will take 2 minus 2, 1, 0 I will take. Next will be 0, 1, minus 1, 0. 1, 1, 1. Substitute. Next 2 minus 2, 1, 0. Next 0, 1, minus 1, 0. Yes, students, what is the answer? Otherwise, directly you can simplify like this. Take these two equations. Yes, how much?
1 by 5, 2 by 5, 2 by 5.
Yes, very good. It is 1 by 5, 2 by 5, and 2 by 5. Very good. The answer is correct.
Sir,
So
this time
therefore,
both are similar only, sir.
now it is similar. See, there something is there, then we have missed. Okay, please check. So is the required fixed probability vector. Okay, So here you can see, so therefore you have to solve both you try, so that you get correct answers. Okay. Similarly, we'll go to the next example. Okay, I'll just read out. Fourth example is very easy. Prove that Markova chain whose transition probability matrix they have given is
Sir,
irreducible.
time is
So
over, sir.
yes, 1 minute I will just show you.
Okay, sir. Okay.
Irreducible is nothing but regular matrix. Regular matrix is always positive. Means I will just give you hint. You can please try yourself. So what is this hint is? They have told that this is already transition matrix. First you have to prove that it is irreducible. Irreducible means it will be regular matrix. Regular matrix is always positive. So please remember these 2 points means you have to show p square is positive, p cube is positive, and p raised to 4 is positive. By using calculator you can calculate. So if all these values are positive, therefore it is, yes, if all are positive, therefore it is proved that this Markova chain whose transition probability matrix is irreducible. Is it clear? Okay, thank you, students. So if you have any doubt, please ask me. Yes, students, if you have any doubt,